So welcome to the course. I'm so excited that you've decided to enroll and learn about the powerful large language model application framework known as LangChain. Before we continue, please make sure that you've read the very first lecture in the course. It's basically just a text article that has links to things like the slide notebooks as well as a resource of the zip file of all the notebooks and datasets we use in the course. So you just got to check the resources for the very first lecture, download the zip, unzip it, and you have the Jupyter notebooks that we work with in this course. Now, in this lecture, we're going to give you a brief overview of how we structured the course and how it relates to LangChain, as well as answer a few quirks about the LangChain documentation. After that, we're going to dive right into coding components with LangChain to build out your own large language model applications. So, a good question is, why LangChain? If you already have access to things like the OpenAI API and the default APIs for other large language models, what's the purpose of using something like LangChain? Well, first off, LangChain is a framework for developing applications that are powered by large language models, and you're not really restricted to any particular large language model. You can use OpenAI's GPT models, or something like Google's Palm 2 or upcoming Gemini models, or really any large language models, including open source models like Llama 2, which was open sourced by Meta. And so this framework does this through the use of modules. And I should point out, depending on where you visit the documentation, you may also see these referred to as components. Although they're technically different, for our use case, we'll just define them as modules. Now, the best way to understand the benefits of LangChain is to understand how these modules and components work together and make it easier to build robust large language model applications. Let's explore the main ideas of these modules or components in relation to the course. Now, before we continue, you're probably a little confused by the fact that sometimes I say modules and sometimes I say components. And this actually stems from the documentation itself, and I'll explain why in a second. On the left-hand side, you can see there's components like schema, models, prompts, memory, chains, and agents. But then on the right-hand side, you see now suddenly they're modules. There's model, data connections, chains, and then some of them have the exact same name, memory, agents, etc. So what's the difference and what's going on here? Well, one of the issues here is that LangChain is not just a Python library, but it's also in development for JavaScript and TypeScript. So depending on which link you click, you'll see them referred to as modules, or you'll see them referred to as just general components. So in this course, we're working with Python, so you'll want to be visiting the Python documentation at python.langchain.com. Sometimes if you do a Google search, you'll actually go straight to the general documentation that then links you to either the Python or JavaScript or TypeScript documentation. And don't be surprised if sometimes the links between the general docs and Python docs are 404. That is, there's kind of a missing link or a missing page there. In general, I would suggest you just go straight to the python.langchain documentation and then visit the modules there. And you can see a stronger connection between this course structure and the modules rather than the components. And I should point out that many of the components are part of the modules. So try not to get too confused with the terminology. At the end of the day, it's not a big deal whether you call them modules or components, as long as you know what they're referring to. So continuing on, this course is basically designed to slowly build up an understanding to something called LangChain agents, which we'll explain in just a second. But essentially, an agent is an extremely powerful large language model based application that allows you to do things like perform really complex tasks and even allows a large language model to perform actions like doing a Wikipedia search or using a calculator to perform calculations with mathematics, etc. And agents themselves within LangChain only require a few lines of code. But jumping straight to agents, because they're one of the coolest parts of the library, can result in confusion about LangChain. So what happens sometimes is advanced users try to jump straight to agents and they get confused because it's just a few lines of code. So then maybe they start at the very beginning of the LangChain docs, which is at model input and output. And then they start getting confused because it's unclear what benefits LangChain provides versus the default APIs. And so what this course is trying to do is frame the modules in a way where their individual utility is quite clear and the motivation behind using even just one of the modules will be clear, along with their quote-unquote synergies once you understand multiple modules. So obviously the modules work very well between each other, but even just on their own, they're really quite useful. And this course is structured in a way to break that down for you. So we've separated out this course into a couple of sections: model input and output, data connection, chains, memory, and then finally agents. And we're slowly building our way towards agents so that once we get there, they make a lot of sense and you can easily just hit the ground running and start building your own agents with their own custom tools. But let's break down the purpose of each of these modules of LangChain. So Model I/O focuses on basic large language model inputs and outputs. And to be honest, this is going to replicate a lot of the functionality that's already present in default APIs. If you're already using the OpenAI API, you may not realize that there's a huge advantage to using LangChain model input and output, but there actually is an advantage. Keep in mind, the LangChain Model I/O, that is inputs and outputs, is standardized. So regardless of what large language model you're using, the code for Model I/O is going to be the same within LangChain. That allows you to easily switch between large language models in the future. And I should point out, it also supports both text completion APIs and chat interface APIs. Language models is a really fast-moving space, so it's great to have a library like LangChain that allows the flexibility to switch between models. For example, right now in this day and age, you may just be working with the OpenAI API. But as Meta releases things like Llama 2, it may actually make sense to switch to an open source model that you're running locally. If you've developed your entire application with LangChain, it's no problem to easily switch your input and output models because you have a standardized framework to work with. A huge advantage and win for LangChain there. Now what about data connection? Data connection focuses on connecting those large language models to some sort of data source. It can be something as simple as your own documents or more complex like a vector store. So what's the LangChain advantage? It allows you to easily swap vector stores, which is a way of vectorizing information and then performing things like similarity lookups. In this course, we use the open source ChromaDB or Chroma database for vector storage, but as you'll soon see, there are a ton of integrations that LangChain allows you to work with. And not only are we talking about vector stores for data connection, but really any sort of data type. You're going to see us be able to connect a model input to a variety of standardized document objects with LangChain that can read in things like CSV files or PDFs, or even connect to AWS, Google Cloud via BigQuery, etc. There are a ton of integrations that are already built in, allowing you to easily switch your model inputs to connect to the correct data source. And then you can take those data sources and easily vectorize them with an embedding call. And LangChain makes this standardized, which is really easy to work with. So now that we have model inputs and outputs and the ability to connect it to any data source, including vectorized data source, what's next? Well, in this case, we get at the core of LangChain by talking about chains. Chains allows you to link the output of one model to be the input of another model call. The LangChain advantage here is you can easily chain together different large language model calls using a Python list to separate out the work between models. You can have one model with a system prompt really specialized in historical context information that has its own vectorized lookup of documentation that has to do with history, and maybe another model that's really good at doing things like using a calculator to perform tasks. And if you set these up in a chain, you now have separated out the work between different large language model calls, allowing you to easily swap components of the chain later on. And this is where the LangChain name comes from, the fact that you can chain model inputs and outputs together. And of course, using LangChain provides you with a standardized framework and format to easily use and be more robust for future proofing to different applications. Once you work with chains, you have memory. Memory allows your models to retain historical context of previous interactions. Here, the LangChain advantage is the ability to easily save historical conversations or results from large language models or chat models and then reload them for future use. You can imagine you have people at an organization using your LangChain application, and then maybe you want to save their historical conversations so that if they turn off their computer and turn it back on, reconnect with your large language model application, you can easily reload from a memory the historical conversation and context that that particular person had. And then finally, there are agents. Agents, of course, are the most powerful part of LangChain. They combine and utilize a lot of the other topics we already discussed, like models, data connections, internal chains, and memory. The real part that is amazing about agents is that they can use tools to reason through requests and perform actions based on observational outputs. And the huge LangChain advantage is that not only can you create agents with just a few lines of code, you can also create your own custom tools for agents to use with just a decorator call. Now, agents essentially are a way of connecting a large language model to tools. And you can think of these tools as anything as simple as using an internal calculator on your computer, all the way to more advanced things, like having a large language model have the ability to do a Wikipedia search for you to help answer a question, or even do things like run Python code. So super powerful tool that people are often really tempted to just go straight to agents, but then it won't really make sense on what these few lines of code are doing if you haven't done your homework, so to speak, on the other modules that we discussed. So what are the thoughts to keep in mind as you're learning about LangChain? As I've mentioned, users new to LangChain sometimes find themselves a little confused or frustrated because they only interact with one particular module, and they miss the larger picture of how these actually interact to create really powerful applications. So this course is meant to guide you step by step so you can see how all the modules work together, meaning you'll want to take the course in order. I highly advise you to not just jump straight to agents. Even though they are super awesome and super cool, they're going to make a lot more sense if you go through the course in order. And I promise that the other modules are also quite interesting and quite useful and cool themselves. Okay, with that being said, let's get started and let's start coding. I'll see you in the next lecture.